Okay, buckaroos and buckarettes, we're going to take a look at this test. This was the Chapter 1 test that we took. You notice up here I gave you these directions: significant figures, units, and use the 5-step system for solving the problems. Well, I certainly looked at that when I was grading it. Here, you know, this goes back to the math pretest that we took, and what we're talking about is multiplying fractions. Again, you need to get used to this. This is the most frequently used math operation we'll use in this class. You notice this vertical line represents the multiplication sign, this one represents the equal sign, okay? So now we're multiplying these fractions, and we're just multiplying across the numerator. 3 multiplied by 4 is 12, 5 multiplied by 7 is 35. Boom, there's your answer. 100% credit, 12 over 35, okay? Here, same but different. Just multiple steps, and I've tried to go over and explain this to you, that what we're going to be doing, let's say for instance we're converting grams to moles to atoms of reactant, or grams to moles of reactant, then moles of reactant to moles of product, then moles of product back to grams of product. We're talking 4 or 5 steps, okay? Here this is only 3. But in the future, in the very near future, you'll be doing these multiplication type deals, these dealing with these as if they were fractions, with many more steps than 4. So here, we're going to multiply 1 times 4 is 8, and 2 is 16. Let's see, no, 1 times 4 is 4, and 2 is 8, and 3 is 24. And here we multiply, we get 27, and 3 is 60. Boom, boom, boom. This is 405. And then, of course, to reduce the fraction, it would come down to 8 over 135. And that's all we're looking at. That's all we're looking at. But an example of how you'd use this is in just the next chapter. When we get into the next chapter, let's suppose we were going to convert inches. We're going to try to convert inches to centimeters, for instance, okay? Well, 1 inch equals 2.54 centimeters, okay? We're going to convert this equality into a conversion factor, and the way we're going to use it is right here. We know we want to cancel units and end up in centimeters, so we'll have centimeters in the numerator, inches in the denominator, and all we have to do is go find that equality. That one should be in your head, but we'll go find that equality, okay? Now, no matter what the quantity of inches, it's no problem. It's no problem. Let's say we're going to do 8.51 inches. Well, we're just going to multiply across the top, 8.51, and we're going to multiply that by 2.54, and that gives us 21.615. That would be 21.615 centimeters. Of course, we've got 3 significant figures here, 3 significant figures here, so we'd reduce that to 3 significant figures. It'd be 21.6 centimeters, okay? But you can see it's the exact same operation we're doing here. That's why it's so critical that you get this down, okay? Now, I'm told frequently that I don't know what I'm doing mathematically, but the way I would do this is I'd multiply both sides by 2. That would get rid of the 2 here, okay? That would give me 64. Would give me 64 equals 4x plus 6y. Now what I would do is I would subtract the 6y, and I'd end up with 4x equals 64 minus 6y, and now I divide by 4, and I'd end up with 16 equals 16x equals 16 minus, divide the 4 in here, x equals 16 minus 1.5y, or 3 over 2y, okay? Here, fairly straightforward. What we're going to do here is we're going to divide both sides by v, and we end up with p equals nRT over v. Okay? Should be no questions about that. Okay? Now you will see some of these again. You will. Okay? That's the first 4. Alright, here we go. We're looking at, let's see, 5. Now this is on page 24. This is a practice section practice problem on sample practice on page 24. It deals with that chart on page 24. And just a little preview here where we're going with this. I want you to understand that this 0709 times 10 to the 0 is the same thing as this, okay? So now if you're looking at scientific notation, if you take this and you increase this by, that'd be the same thing as multiplying by 10 again, and multiply by 10 again. Now that would put our prescript where it belongs, 7.09 times 10 to the, not the 0, we multiplied this 3 times, so we have to make this smaller by 3, so it would be -3. Now in that version, everybody knows it's 3 significant figures. If you just look at the table on page 24, you know that the 0 digits after the decimal place but before the first non-zero digit are not significant. So those are not significant figures, okay? The 0 between two non-zero digits are always significant. So that is 3 significant figures. Okay? Need to look at those and make sure you understand that. Now here's a simple rule. We're multiplying 3 significant figures by, so here we're multiplying 3 significant digits by 2 significant digits. Our rule tells us that our answer can only have as many significant digits as we have in the value with the least number of significant digits. We have 2 significant figures here, we have 3 significant figures here, so we can only end up with 3 here. Now our units, interesting enough, do not cancel. So the correct units for this, which it doesn't make any sense, it's kind of screwy, it's actually a mistake, but it would be gram centimeters cubed. Anyway, our values come out like this. They come out to 70.9. I think I have 933, okay? And like I said, that's gram centimeter cubed. Well, we have to reduce this to 2 significant figures, okay? So we have to express 70.933 as close as we can with 2 digits. Well, that's pretty obvious. It's got to be 71. You got to go up, okay? That's it. Now this one, you know, here we're multiplying, up here we're dividing, okay? So you have the same basic rules. You got 4 significant figures here, and you have 3 significant figures here. So your answer is going to have to be in 3 significant figures. You can see that right off the bat, okay? So you have 56.05 grams divided by 13.3 cubic centimeters. No units cancel, so you're going to end up with grams per cubic centimeter, which makes perfectly sense. You got mass over volume. And what you come out with here is 4.21, I believe it's 4.2142, okay? Well, we have to reduce this to 3 significant figures. We've got 1, 2, 3, 4, 5 here, so the best way to express this figure in 3 significant figures is to leave that 1 right there like it is and do not go up, because that's a 4. So that's going to be 4.21. Okay, now this is a little bit different. We're doing addition. Addition and subtraction, you're actually tracking the decimal place. So this is going to be 1.057. That's a thousandth, 7 thousandths. Okay, here it's 3.02. That's 2 hundredths, and then here it's 12.4. That's 4 tenths. So remember that in these measurements, the last digit is always estimated. So here you estimated tenths. Well, you certainly can't go and estimate hundredths behind an estimated tenths, or certainly thousandths behind an estimated tenths. So your answer is going to have to stop at the tenths, okay? This comes out to 16.477. Of course, the unit's grams, but you can't go past the tenths mark, okay? So this is 7, so it means you're going to have to round that 4 up to 5. So the answer here is 16.5 grams. Okay, now we've beaten this horse almost to death. Density is equal to mass over volume. Okay? Everybody's comfortable with that, I hope. Okay? Now, if density is equal to mass over volume, then mass must be equal, density is equal to mass over volume. The way I solve for it is I multiply both sides times volume. Okay? So the volumes cancel over here, so mass equals density times volume. Piece of cake, right? Okay, you got to get that down. It's got to become comfortable for you. Okay, so now here we're looking for volume again. Density equals mass over volume. Now, if you have trouble with solving for variables that are in the denominator, then what you want to do is just invert both sides. Okay, invert both sides. You can say then that 1 over d equals v over m, and the v is no longer in the denominator. Otherwise, what you could do here, and the way I approach it is I would multiply both sides times v, and then I would divide by d. In either case, I'm going to end up with the fact that volume equals mass over density. It's going to be mass over density. Okay? No problem. Now, what I'm trying to do is set you up so you don't make these mistakes. This is step number 3 in these questions. Okay? Alright, so let's take a look. If we look at our 5-step rule, the first thing we do is we restate the equation or the law. In this case, asking you for density is clearly m over v. Step 2 says identify the variables and match them with the given values. Okay, so the first thing you're given there is mass, and that's 42.56 grams. The next thing you're given there is volume, and that's 25.98 cubic centimeters. Okay, and then step 3, you've got 3 variables here. You're given 2 of them, so the one you're missing is density, and density equals mass over volume. Step 4, plug in the values, which is just a restatement of what you just did. 42.56 grams divided by 25.98 cubic centimeters, and you can see that your units aren't going to cancel. You're going to end up in grams over cubic centimeters, and that's exactly what you'd expect for density. Okay, so you now and only now you plug in your calculator and you come up with 1.63818. This equals 1.63818. Well, you have 4 significant figures, so your answer has to be in 4 significant figures. Okay, 1638, that's a 1, so you're going to drop it. Okay, so it'll be 1.638 grams per cubic centimeter. Okay, 13, we're looking again. It says we have a density. Okay, so what do you know about density? Everything. Density equals mass over volume. Step 2, we're going to identify the missing variable, identify the variables, and match them with the values that are given. Well, the first thing that's given to us is a density, 2.70 grams per milliliter, and then we are given a volume. Volume equals 45.67 cubic centimeters. And you say to yourself, self, I got a unit problem here. I got milliliters here and cubic centimeters here. Not to worry. This is to help you remember that a milliliter is the same volume as a cubic centimeter. This cubic centimeter is a derived unit. It means that you got a centimeter deep by a centimeter wide by a centimeter tall. Okay, and what that would do is that would hold 1 milliliter. 1 milliliter would fit in that volume. Okay, so anyway, we go to step 3. We see that this is our equation. We got a d, an m, and a v. We're given the d and the v, so we must be solving for the m. And the m we look at and we solve and multiply both sides times v, and we say that m is equal to density times volume. Okay, so then we go to step 4 and plug in the values. The density is 2.70 grams per. You can either use milliliters or cubic centimeters. I'm going to use cubic centimeters because I know that's aluminum. And then the volume is 45.67 cubic centimeters. And then look at here. The cubic centimeters are going to cancel. So we're going to end up in grams. And that's exactly what you would hope if you're solving for mass. So you haven't touched your calculator yet, but you know you're on the right track. Your units cancel out correctly. So here we come out to 123 point, what is it, 039 grams. Okay, well, we have 4 significant figures here, and we have 3 significant figures here, so we're going to have to put our answer in 3 significant figures. Since that's a 0, that's a no-brainer. That's a 1, 2, 3. Use the decimal, okay? All right, now, 14, again, another density problem. How do I know? Because boom, says density right there. So when we see density, we know this is what we're dealing with, some version of this, mass over volume. 2, again, we're given the density, and this time it's 8.96 grams per milliliter. Now we're given the mass, and the mass equals 426.53 grams. And so we got D, an M, and a V. We got the D and the M, so we must be solving for the V. The volume we looked at before, again, we know is equal to the mass divided by density. So we solve for step 4. Step 4 says plug in the values, and we've got a mass of 426.53 grams, and we have a density of 8.96 grams per cubic centimeter or per milliliter. Okay, and so let's see what we did here. And so what we want to do here is we look at grams over grams, they cancel, and we're going to end up with 1 over 1 over milliliters. Well, we know that equals milliliters, and that's a good thing because we're solving for volume. It's exactly what we should have. Okay, so this is going to take us to our step 5, and this calculates out to 47.60379. Well, let's see. We've got 5 significant figures here, and we've got 3 significant figures here, so our answer has to be 3. The 4, the 7, the 6 are going to stay. Since that's a 0, we're not going to round the 6 up, and we're certainly not going to drop it down, so we have 47.6 milliliters. Okay, that's the correct answer, 3 significant figures. Now, the last question was asking about, I don't know how to get there from here. Let me see if I can find it here. No, the last question was asking about whether density is intensive or extensive. Density is an intensive property. Intensive means that it has to do with the composition or the makeup or the properties of the substance. Extensive has to do with the size of the sample. In other words, an extensive property would be the volume of a piece of metal, or the mass of a piece of metal, or that sort of thing. The intensive properties are things that don't change regardless of the sample size, like boiling point, specific heat, conductivity, energy per unit gram, and density, that sort of thing. Okay, so very straightforward. You need to go through this, make sure you understand every single question on this test, or they're all subject to come back at you again. Okay, and if you have any questions, look at the video, try to follow what I did. If you have any questions about any step anywhere, please ask. All right, thank you and good luck. See you next time.